For this lesson, we're going to be taking a look at angles in the Cartesian plane. So that's the XY plane. For most of you, you're probably familiar with the idea of angles within various geometric shapes. In particular, we do a lot of focusing on angles within triangles. And this is going to make its way back to there in upcoming lessons. But there's some terminology and some concepts that we're going to go through here that really just apply to angles. It has nothing to do with triangles in particular. So first of all, some terminology. When we're describing or when we're making an angle, one way that we can do this is the notion of we start off with an initial arm or a ray. So it's a ray, it means it's from here to there with an arrow at the end. You could think of that like a vector if you're familiar with it. It's not quite the same thing. So we're just going to call this the initial arm. And then if I imagined rotating that arm to this new position, that would be called the terminal arm. That's where the rotation ends. So the initial arm to the terminal arm, that's going to describe a particular angle. The convention for this is if my rotation is counterclockwise, which is what is shown here, then that would be a positive angle. And if the rotation is clockwise, that's going to be a negative angle. So you can see the direction of the rotation from the arrows. So in this case, I've kept my color coding from before. My initial arm is green, my terminal arm is red, and my angle of rotation is indicated by the purple arrow, the curved arrow there. So this one is positive 120 degrees. My initial arm is green, my terminal arm is red, and my angle of rotation, in this case because it's clockwise, is negative 40 degrees. Now if you have just regular pencil and paper, or if you're seeing something on a test, you don't have color coding. How do I know the green and red? You don't actually need that, because when you see the rotation, it's going to be something like this. It starts here and it ends here. It always ends where the arrow is pointing. So that's how you know where the rotation started and where it ended. Okay, so now we're going to actually get into the Cartesian plane, or we're certainly going to end up looking at something here that's going to resemble the Cartesian plane. One of the things we're going to be talking about is something known as standard position. In standard position, the vertex is the point that we're rotating around. So you can see we've got the terminal arm out here to the right, and it rotates. In this case, I'm showing it as rotated counterclockwise. And the point of rotation is the origin. So if I were, for example, to take this arrow and continue to rotate it, notice how the base of the arrow is still at the origin. That is a requirement of standard position. So the vertex is at the origin. That's the first part. And then the initial arm is on the x-axis. So the previous diagram that I showed you, this is not standard position because I haven't specified where the origin is. And also, even if, let's say I put the origin here with an x and y axis, that is still not standard position because this initial arm is not along the x-axis. So it's only when those two things are combined, which they are here. Here's the x-axis and here's the y-axis. It's only when these things are combined that we have standard position. And the majority, perhaps everything that we do with respect to this is going to be in standard position. Now that means if I start here on my initial arm and I start going in the positive direction of rotation, this first 90 degrees is going to be in the first quadrant. So this is also known as quadrant 1. Sometimes we write it short form Q1. When I get past 90 degrees, so let's pick this up, and if I keep rotating it, there it's at 90 degrees. If I get past 90 degrees, I'm over in quadrant 2, and that lasts until I make it to 180. Then I cross over. Now I'm in quadrant 3. If we were drawing this as an arc, as a rotation, it would look something like that. We're still starting on the initial arm, and then we're rotating around to the terminal arm, and I carry on into quadrant 4. And what kind of angles? Well, here's 270 degrees, so now this is greater than 270. And then once I make it back to here, I'm back, that's 360 degrees, I'm back at 0. So if I keep going from there, which I can do, you just need to recognize it's kind of like bearings, which we talked about in a previous lesson. So once I come all the way around, I'm at 360, I start over at 0 in general. And first, second, third, fourth, we're going to make quite a bit of use of the idea of quadrants here. And you do need to remember the angles that go with the positive x-axis, the positive y-axis, the negative x-axis, and the negative y-axis. They're just increments of 90 degrees. Okay, so I mentioned that once you rotate all the way around and get to 360, it's just going to roll back over to 0. When we talk about angles like that, those are principal angles, an angle between 0 and 360 degrees. It is possible to have a larger angle than 360 degrees, or to have an angle that's less than 0. An angle like that would be called a coterminal angle. What that means is that any pair of initial arm and terminal arm can be expressed in terms of a principal angle, but then technically there are an infinite number of terminal angles. So for example, here is a principal angle of 60 degrees between the initial arm and the terminal arm. But imagine, and actually I can show you that happening here. Imagine I took this terminal arm. Oh, maybe I can't show you. Let's see, ungroup this. Nope, I can't show you. This is all locked together. So instead, imagine that I started rotating through that 60 degrees, and then I continued all the way around. So now if I made it all the way back from here back to the green initial arm, that's 360 degrees. But then I went to the terminal arm again. That's another 60. So that would be 60 plus 360 is a total of 420 degrees. So this purple spiral is a coterminal angle. It's not a principal angle because it's greater than 360 degrees, but it is coterminal. It means that the angle 420 degrees and the angle 60 degrees actually describe the same picture. Another thing that we make a lot of use of, so much so that I want to star this. This is a hugely important idea. The related acute angle or the reference angle, quite often referred to as the RAA, which is the terminology that I tend to use, but I also have other teachers who will refer to that as the RA, the reference angle. Both of them are correct. It's not that one is more correct than the other. It's just a terminology. The related acute angle or the reference angle, it's the angle formed between the terminal arm and the x-axis, and in particular, it's the closest part of the x-axis. When we look at the related acute angle, we don't concern ourselves with direction, clockwise or counterclockwise. It is always positive, and it must always be an acute angle. It's right there in the name. It is the related acute angle. Now, let's see. We've actually got some exercises coming up here, and those are going to help me to illustrate these things. So rather than drawing a diagram for this right now, I'm going to explain this as we go through these exercises. The first one just wants you to show the terminal arm. Your initial arm is going to be, as it was before, let's see, I don't have a handy one here. I'm just going to freehand it then. Your initial arm is the positive x-axis. The terminal arm, and I'm going to use the same color I did before, your terminal arm here is at 50 degrees. Well, the x-axis is 0 degrees. The positive y-axis is 90 degrees. So 50 degrees has to be not quite in the middle here. It's a little bit past the middle. I am just freehanding it, so it doesn't have to be exactly correct. And So that would mean that this, it's positive, so this would be the angle at, or this would be the terminal arm that goes at an angle of 50 degrees. Once again, let's go to the next one. I'm going to stop doing this in a moment. I'm not going to draw the initial arm every time. So there's my initial arm. The initial arm is on the positive x-axis. So there's the x-axis, which is at 0 degrees. Here's the y-axis, which is at 90 degrees. Here's the negative x-axis, which is at 180 degrees. And here's the negative y-axis, which is at 270 degrees. So where's 130? And remember, it's positive 130. So where's that going to be? It's going to be partway between 90 and 180. So maybe something like that, just freehanding it again. So that means this is my angle. It's a positive angle, 130 degrees. And this is my terminal arm, this red arrow. How about 300 degrees? All right, so I'm not going to do the color coding anymore. I'm not going to draw the terminal arm, but I'm going to fill in my angles here because I still think that's helpful. 0 degrees, 90 degrees, 180 degrees, a little bit more room at the bottom here, 270 degrees. So where's 300 going to be? 300 is going to be just a little bit further than 270. There is my rotation angle, which in this case is 300 degrees. And here is my terminal arm, the arrow itself. This last one is interesting just by virtue of the fact that we finally introduced a negative angle. So we may know that this is 0 degrees, 90 degrees, 180 degrees, and 270 degrees. But for negative angles, we have to rethink this. This is still 0 degrees. That hasn't changed. But for negative angles, we go this way. So this is negative 90 degrees. This would be negative 180 degrees. This would be negative 270 degrees if we're going clockwise this time. So where's negative 210? Negative 90, negative 180, negative 270. Negative 210 must be in here somewhere in quadrant 2. So it must be there. And don't forget to draw it. The rotation is here this time. It's clockwise. A rotation of negative 210 degrees. And our terminal arm is right there, that straight arrow that I've drawn. All right, state the principal angle of 463 degrees. Now you can do this with a diagram, or you can do it with arithmetic or algebra. I think I'm going to start with a diagram for this one, and just a little freehand diagram. It's positive 460 degrees. Sorry, 463 degrees. So if I start drawing a loop, if I draw my first spiral to there, how far have I gone? I've gone 360 degrees. So I still have further to go. How much further do I have to go? Well, why don't I subtract 360 degrees because I've already gone 360 degrees. So if I subtract 360 degrees, what answer do I get? 463 minus 360 gives me 103 degrees. So I've already gone around 360 degrees. I need to go another 103 degrees. That means I need to go a little bit further than 90 degrees, which gives me a terminal arm about there. And so the principal angle is just that little extra piece that I had to do. So the way we might write that from a terminology point of view is we might just say here that the principal angle is equal to 103 degrees. Just going to rewrite that. 103 degrees. Now, what about this one, 940? I could go through the same process. But the thing to keep in mind is that every time I do one of those loops, I'm going 360 degrees. So I'm actually going to just start by subtracting 360 degrees from this. 940 minus 360 gives me 580. But 580 degrees is still too big. So I do 580 degrees minus 360 degrees, and that one gives me 220 degrees. 220 degrees is between 0 and 360. This is the principal angle. So the principal angle is equal to 220 degrees. Now, negative 387, we want a principal angle. And principal angles, just to remind you, are between 0 degrees and 360 degrees. And this is a little bit misleading. I'm going to actually use our set notation. A principal angle should be between 0 degrees, including 0, and 360 degrees, but not including 360. That's why I use the round bracket there. Because once we get to 360, technically we're back to 0 again. Now, for this one, I think I need another diagram to show you this one. Where is negative 387 degrees? So let me start by going negative 360 degrees. So if I use up negative 360 from this, that's going to be the same as if I added 360. Notice for the positive angles, I subtracted 360. For a negative angle, I add 360. And that gives me what? That's going to give me negative 27 degrees. So where would negative 27 degrees? That would be just a little bit further this way. And so my terminal arm would be there. But we want a principal angle. And so what I really want to measure is actually from here around to that terminal arm. And so we take this negative 27 degrees, and the easiest way to do this is to actually add another 360 degrees, because we're trying to get a principal angle between 0 and 360. But negative 27 plus 360, that's the same as 360 minus 27, which gives me an answer of 333 degrees. So that's what we have. This blue one would be 333 degrees. And so we would state that as our answer. Our principal angle is 333 degrees. Now, exercise 3, state a positive and negative coterminal angle. 115 degrees. Where is that? Let me clean that up a little bit, a little more horizontal. This one is 90 degrees. This one is 180 degrees. So 115 is up here. I want another coterminal angle that's positive. Well, the easiest way to do that is to take the 115 degrees that I already have and then add to that an extra 360. Another way that I could do the same thing, and this is going to get messy, so let me take away that first one. Another way that I could find a coterminal angle, in particular a negative one, is go forward by 115 and then go backward by 360. So coterminal angle number 1 is going to be 115 plus 360 degrees, which in this case works out to be 475 degrees. And coterminal angle number 2 is going to be 115 minus 360 degrees, which is going to be equal to 245 degrees. Sorry, negative 245 degrees. For 28 degrees, now I'm not going to draw the diagram. It's the same idea. Coterminal number 1 is going to be 28 degrees plus 360 degrees, which is going to give me 388 degrees. Coterminal angle number 2 is 28 degrees minus 360 degrees. And that's going to give me, in this case, negative 332 degrees. Finally, we're looking at the reference angle or the related acute angle for 135. So first of all, locate 135 degrees, 0 degrees, 90 degrees, 180 degrees. I don't need 270 because 180 is as high as I needed. 135 is here. So there is 135 degrees. The definition of the reference angle or the related acute angle is the acute angle between your terminal arm and the nearest part of the x-axis. It's the x-axis. So what is the nearest part of the x-axis to this terminal arm? The negative x-axis or the positive, and it's quite obvious it's the negative x-axis. So this angle is going to be my reference angle or my related acute angle. And what you should notice from these, there's a couple of ways to do these. As you get more comfortable with this, you'll see different ways to do it. But what you want to do is you basically want to make use of this 180. You're always going to be referring to either 0, 360 degrees, or 180 degrees. Now in this case, because we're closest to 180, that's the relationship we're going to make. You could write this a couple of ways. You could write that the related acute angle plus 135 degrees must be equal to 180 degrees. Or you could go straight to the fact that the related acute angle is 180 degrees minus 135 degrees, which in this case is going to give us 45 degrees. So you can start here if you want to, but you are welcome to go straight to this subtraction. How about 276? 0 degrees, 90 degrees, 180 degrees, 270 degrees. 276 is just a little bit further than 270. When you're drawing it, it's never a bad idea to exaggerate that. Your drawings are not meant to be to scale here. No one's going to measure these angles using a protractor. So there's my angle. From here to here is 276 degrees. We are interested in the related acute angle, which is there, because the closest x-axis is the positive x-axis in this case. There's my related acute angle. What is the relationship between these things? The easiest relationship is just to make a full, in this case, to make the full circle. That means this thing is a full circle is 360. The related acute angle plus the original 276 degrees must add up to a full circle because it brings you all the way back to the x-axis. Or once you become more comfortable with this, you could write this as the related acute angle is simply equal to 360 minus 276 degrees. And in this case, my related acute angle is going to be equal to 84 degrees. Notice these angles are both angles that are less than 90. Notice these angles are positive angles. It has nothing to do with direction. Once you're dealing with a related acute angle, it has nothing to do with direction anymore. We're ignoring direction. We're basically just looking at these relationships, adding up angles to get to certain totals. Determine reference angles here, and then now I'm introducing a negative angle, but you need to keep in mind what I just said, which is I don't care about positive or negative. Related acute angles are always positive, but I do need to identify where this is. Here's 0 degrees, but I'm going the other way, so I'm going to actually label my axes this way. Where is negative 145? Looks like it's over here. So there's my negative 145 degrees. And my related acute angle is going to be there. Now this is where things can start to get complicated, because remember, the related acute angle is supposed to be positive. So you might do this. The related acute angle plus negative 145 degrees is equal to negative 180 degrees, which means the related acute angle is equal to negative 180 degrees plus 145 degrees. And so from there, I end up with the related acute angle is equal to negative 35 degrees. And if you go this route, you just need to recognize, but the related acute angle is always greater than or equal to 0, which means our related acute angle must be 35 degrees. Or the other way you can do this is you can just reason it out that this angle has to be 35 degrees away, because this is just the mirror image of it on the top side here. I think this is probably the best way to do it until you get a really good intuition for it. Once you get better with these things, you'll start to see the answers. You'll start to do the arithmetic in your head or in the calculator. With related acute angles, all you have to do is state them. You just have to tell me what the related acute angle is. To be honest, the related acute angle is going to be the first step in multiple steps you're going to take. So identifying this does not require all of this. I'm putting this here so you understand where it's coming from. What about this one? 195 degrees. That means I'm going to use positive angles for labeling. 195 degrees is a little bit past this 180, so it's there. 195 degrees. And now I need my related acute angle, which is here. Now this is a new configuration because my related acute angle is actually contained in my original angle. So how do I deal with that? The way to deal with that is to say that the related acute angle went past 180 degrees to end up with our principal angle. So the way we write this one is a little bit different. The related acute angle plus 180 degrees must be equal to 195 degrees. The negative x-axis is 180 plus a little bit. The negative x-axis plus a little bit has to be equal to 195. But that's just another way of saying the related acute angle is 195 degrees minus 180 degrees, which in this case is positive 15 degrees. And that is it for this lesson. Hopefully you found that to be relatively straightforward. I have a handout for your homework, and I can easily generate more of these types of questions. So if you experience any difficulty with any of the questions on this handout, just let me know and I can give you many more to practice on until you have this locked down. Related acute angles in particular are super important. So if you're having any struggle with that, ask for some additional practice.